All right, so now we're looking at linear functions and word problems, and I want to just put in here contextual problems. Okay, call them contextual problems because there's some context to them. Now, some of the problems, okay, can be solved using linear functions. And we often see these ones as ones that are kind of like growing or going down or something along those lines. Okay, and we can use that to represent a situation, whatever that situation might be. And now, again, when we say contextual, we're usually talking about real world examples or ones that we might see outside of the math classroom. Okay, it's not just formula. No, now it's actually some sort of real life or contextual problem. When a straight line graph is drawn from the information, okay, it can be represented by a linear function, and I'm going to put in the brackets here, equation. Okay, so we can represent it with an equation there as well. So let's take a look at what that means using an example here. So a cell phone plan charges a monthly fee that covers the cost of the first 300 minutes of phone use, and this graph represents the cost of the plan based on the time beyond 300 minutes. Now this is a little bit, maybe not current because we don't really talk on the phone a whole lot anymore. Used to be. When I was younger, we would talk on the phone all the time because there was no such thing as texting or Instagram or Snapchat or any of those. But things have changed a little bit. But we're going to go back a little bit. So let's say that we have a cell phone plan, and the first 300 minutes of your phone plan, or maybe we could change it to gigabytes. So let's say the first 3 gigabytes of data is going to be covered, but then any gigabytes that you use on top of that as data, or in this case minutes, okay, is in fact you're going to get charged a certain amount for it. So this is a graph which represents that cost. You'll notice here that the time that's used beyond 300 minutes is represented here, and the cost is represented here. So the more minutes that we use, the higher the cost, and that's what these points all represent. Now, how do we know that this is a graph of a linear function? Well, it is a straight lined graph. Okay, it's a straight line graph. It goes in a straight line. There's no curve to it. If there was curve, then it would have to be something else. If it wasn't exact, it would be something else. This is a straight line graph, so it is in fact a linear function. Now, the slope of this graph, okay, so remember that m is always rise over run. What does the slope represent? Well, the rise is the change in cost. So the rise is going to be the cost, and the run is the number of minutes used, so it's the cost per minute used. Okay, think of that. That's a rate, right? The cost per minute used. So it's how much it's going to be cost based on the number of minutes that you're using. Okay, or based on each minute that you're using. That's going to be our slope. Okay, and we can find the slope here, rise over run, and we have 1 point here and 1 point there. And I'm going to use a different color to represent our slope. And I'm going to draw that out. Well, there we go. There's my other ruler. I keep losing my rulers for whatever reason. Even though I'm at my desk in my basement here, I keep losing them. Maybe it's underneath papers. That could be it. My desk at home is almost as messy as the desk at work. All right. So this is going to be our run, and this is going to be our rise. Okay, and we're going to find what is the slope. Now the run is from here to there. Now we can't just count them out because this doesn't going up by ones, it's going up by tens. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It goes from 0 to 100. So we have a run of 100 minutes. Our rise, now this again, it's not going up by ones, it's going up by fives. So we're going from 20 up to 50, which is a change of 30. And if we put that into lowest terms, that's 3 over 10. So it's a cost of $3 per 10 minutes. Okay, $3 per 10 minutes. That is what our slope is going to represent. Now let's come up with an equation which represents this function. Y equals mx plus b. We're using slope-intercept form for that. And move it up so you can see it again. Try to keep that in place. Now this equation here, the y is representing our y, which is going to be our cost. So we're actually going to change that to c. Our cost is equal to our slope, which we found was 3 over 10. x is this one, that's our n, so 3 over 10 n, number of minutes. And our y-intercept is this point right here, which is at 20. Okay, so that's at 20, so we're adding 20. That's going to be our equation. So the cost is equal to 3 over 10n plus 20. Y is the cost, m is the slope, x is our n value, or the number of minutes, and our y-intercept is 20, right there. Okay, so that represents that right there. Now to verify that our equation is correct, we might want to take a point that we know is going to work, and I'm going to take this one up here, 150. It's not 150, it's 100, and then 50 is our second one. And let's see if that works for this here. If our number of minutes is 100, do we get 50 as our cost? And we should. Hopefully we do. So I'm just going to pull this down a little bit so that we can all see it. When we plug that in, we're just going to try to find the cost when the number of minutes is 100. Okay, so we plug the 100 into our equation, and this is what we call verifying, just double checking to see if it works. And so we're going to do 3 over 10 times 100. You could also do 3 divided by 10 instead of 3 over 10. My calculator, I like fractions. If you like decimals, you can do 3 over 10, 3 divided by 10, multiply by 100, and then we add 20, and we get that our cost is $50, and that is verified. That works. We did it correctly. Okay, we're getting the correct values. We could find that one too. We could find that one there. We could find all sorts of different ones if we would, in fact, like to. Okay, and that's confirmed. Now, just to continue on, I know this video is getting a little bit long, but I want to go through this last little bit as it is helpful and it is part of that. Actually, no, we're going to go through that in another video.